हमको नहीं मिला।
Hello everyone and welcome back to our second edition of CLEAP Conference 2022. CLEAPCon started in 2021 to raise awareness about cybersecurity in the world. And in this conference, we cover all novel and new topics under the security domain. Since that time, it has annually brought together a lot of leaders from industry, government, academics, and security researchers. And we are down with our last two sessions. And what best can be to give an end to this conference with my best and two consultants from CLEAP Technology. First, I introduce Alia, who will be taking a session on API hacking. Pooja, please introduce Alia.
Thank you, Shivani. So now I'm going to introduce my colleague Alia Verma, who is talented and supportive. She plays an active part in building a community around ClipCon. She started her cybersecurity journey in 2019. From then to now, she's unstoppable. And she's a tech speaker who loves to talk about cybersecurity topics. She's working with us as a information security consultant. And today she's going to talk about introduction to API hacking. So please welcome Alia Verma.
Thank you, Pooja ma'am.
Yeah.
I'm happy to be here, happy to be a part of CLEAPCon this year. So I think I should just get started.
Yes.
I hope my slides are visible.
Yes.
Yeah, and my voice is also audible.
Yes.
Okay, thank you, ma'am. Hello, everyone. I am Alia Verma, and we are here for a quick session on introduction to API hacking. So let's get started. So today's agenda, or I should say this session's agenda, to get introduced to a less traversed domain. API in specific, or API as a technology, is very evolving, is in fact forever evolving, and therefore this domain is less traversed or yet to be fully explored. And that's why we are here to, just get introduced to this API hacking domain. Here's a quick who am I. So hello, everyone. I am Alia Verma. I am a cybersecurity enthusiast. I work as an information security consultant at CLEAP, and I'm also a CTF player. So in my free time, I love playing CTFs, and this is my LinkedIn handle. You can always reach out to me here. So let's talk about like the prerequisites of API hacking, or prerequisites for the session. To be honest, there's none, because we'll be starting from the very basics. But a little knowledge in web is always worthwhile. So let's get started. So I think it's very important to ask these questions to ourselves: why before how? And when I, for the first time, started learning about API hacking, I asked the same question to myself, that why I need to learn API hacking, or why it's so important. So here were the three answers to my question, like why I need to learn API hacking. APIs are everywhere. They power everything, from web applications to e-commerce platforms, to streaming services, to booking apps, to banking apps, to social media, even our devices, even laptops, mobile phones, everything. APIs power everything. And just to share like a little bit of data, today API calls comprise more than 80% of all web traffic. This shows how important APIs are. And specifically, advancement of IoT devices. Just we can see that IoT devices are getting connected with each other, and even the devices which were not so digitally connected to the internet before are getting connected today. For example, watches. Watches are, we are more using smart watches today. And that's one of the examples. So these were the three main reasons why I got started with API hacking. But once I got started with it and I started learning more and more about it, I got to know something more. So very little is being done to secure APIs. API in itself is a domain which is, again, I would say, very less traversed, and there's a lot that needs to be done, because somehow what happens is that people have kept on assuming that websites are more important, and APIs somehow do not reveal so much of sensitive data, or APIs cannot be a matter of threat. But that's totally wrong. APIs carry information, and these information are totally sensitive information, and these need to be secured. So what is an API? The full form for an API is Application Programming Interface. Well, that name just doesn't do a lot of justice to it. It doesn't explain what exactly an API is. I'll give a quick or a very simple definition. API is a set of protocols and procedures, or is a basic or simply a set of code that allows two applications to communicate with one another. Looking at the picture on the left, there are so many devices and applications over here. And it's very important to understand that all of these applications and devices are heavily dependent on APIs. And some very common, very popular APIs, if I have to talk about, they would be Google Maps APIs, or booking APIs, like it could be for anything, booking hotels, tickets, or cabs, anything, all of these, even our transaction-based APIs. And weather-based APIs is another common one, which is like very, very frequently we get to interact with. Moving further. So how an API works. So I think this is a very important structure to understand, like how an API works. API is not just a specific application that works, or it's not a database, it's not a web server. And how it actually works is very important to know. So I came across something very interesting while I was learning about APIs when I started. And it said something like, API is not a database. API is not a web server. API is the code that governs the access points of a web server. So I think this sounds very relevant today to me. And I will just quickly explain what exactly or how exactly an API works. So let's say on a web application, a user makes a request. For example, for this sake, for our understanding, we can assume that it's an e-commerce platform and the user is trying to access order details. So a user makes a request to fetch order details. That request directly goes to the web server. And what the web server does is that it forwards that request to the database. So the database fetches the order details and responds back to the browser. And here the browser received on the web application, or on the response received on the web application of the browser gives all the details of the order details about the user. So moving further, we have the API gateway. API gateway is a very important topic which is usually overlooked. So we'll quickly take a look at this. So this is, again, an example for an e-commerce website. So there are different microservices involved. There's cart, there's catalog, there's search, and there are many more other microservices. So let's say the user makes a request to catalog microservice. That request goes through the API gateway. API gateway here acts as an abstraction layer. So what happens is that the API gateway forwards that specific API request to the allotted or to the assigned microservice. So this is something very important, because there are different devices involved. Today, we are using mobile phones to access internet. Today, we are using laptops and smartwatches and all the other kinds of applications. So all the other kinds of devices. So it's important to have like a common gateway through which all the requests can be equally distributed or distributed to the assigned microservices. So that's very important to understand. And then we can move forward to the part where we can discuss the security aspect of the API gateway. So in terms of security, API gateways are very important, because API gateways, filter bad requests, they monitor incoming traffic, and they route all the requests. They route the request to the exact microservice. That's something very important. And even if we have to talk in terms of authentication, authorization, or load balancing, rate limiting, all of these are handled by API gateways. So again, this is a very important topic to look at. So I think this is clear. We'll move to the next part. There are different types of APIs. So these are the four main types of APIs. There's public APIs, internal APIs, partner APIs, composite APIs. Talking about public APIs, these are also referred to as open APIs. So the public APIs do not require any kind of authentication. They are open for anyone. They are open for the public to use. Talking about the internal APIs, these are also called private APIs, and these are user specific. They are not open to everyone like the public APIs. For example, there's a bank, and what happens is that banks have like different needs. They have their different requirements, and based on that, they create different APIs. What happens is that these APIs should not be accessed by everyone. These APIs should not be accessed by public, or these APIs should only be restricted to the people who are supposed to work with. That's why these are important. Talking about partner APIs, so they are meant for extending resources to third party. So these are different from internal APIs. These should not be confused with internal APIs, because what happens is that these APIs are not being used within an organization, but these APIs are being used with the third party. So if an organization wants to share their resources only with the third party, that's when partner APIs come into the picture. Lastly, we'll talk about composite APIs. So it's a mix of different types of APIs, and this is basically done to achieve efficiency. So we'll move to the next part. So there are different API architectures. So here I'll be talking about like 5 different API architectures. So again, this is not an exhaustive list. This is like the list of 5 most common APIs. First one is REST. REST is the most common form of API architecture. I should say common and most importantly popular, because 70% of all the public APIs are REST APIs. So this is very important, and a lot of it today will be REST APIs. Talking about SOAP. So SOAP has been important in the past, but today it will be rarely found. Next, we have GraphQL. So this is another API technology. GraphQL is fairly new, and in fact, the newest when compared to all of these APIs. Then we have XML RPC and JSON RPC. So these are like RPC-based APIs, and they are like encoded in respective XML and JSON. So we'll take a look at the REST API. So REST stands for Representational State Transfer APIs. And as I said, these are most commonly used architectures. They return data either in JSON or clear text format. These are stateless. By stateless, I mean that the provider does not need to remember the consumer for every single request that the consumer has made. And these are lighter, more flexible, and less complex. So the reason why REST APIs are less complex is because these are stateless. We'll move to the SOAP APIs. So SOAP stands for Simple Object Access Protocol, and it is exactly not an architecture, but more of a protocol that builds on REST APIs, and it uses strict security standards. And these are often used in environments which require higher requires higher security standards, and they have to deal with sensitive data. For example, banking. So that's one thing. And again, I would say that SOAP APIs these days are not that common. You will rarely find SOAP APIs. I'll move to the next part. So next we have GraphQL. GraphQL is very new as compared to rest of the APIs, like as compared to other APIs. So it's a query language. In fact, again, it's not an architecture, but a query language for APIs. It takes a query-centric approach and allows you to request specific as well as multiple resources with just a single API call. So what it does is that it allows a developer, or it allows users to fetch resources as per their convenience or as per their requirements. It's not that if they make a single request, they have to get all the details, all the resources that are contained within it. And in fact, they can choose from it. That's a very important part. And most importantly, they can make multiple resources. They can access multiple resources with just one single API call. So that is very important. And that's why it is getting very popular these days. And but still it's not that widely used when compared to REST. And lastly, we have JSON RPC and XML RPC. So these are lightweight remote procedure call protocols. It is These are like encoded in JSON and XML respectively. And again, these are stateless. So we'll be moving forward, keeping REST in our mind, because the REST API in our minds, because REST API, as I said, is very commonly used and is again 70% of all the public APIs. So that's something you will find a lot more than any other form of API. So it's important to understand the CRUD or the CRUD operations. So CRUD, these are the 4 fundamental database commands. Each alphabet in this represents something, and it has like a respective HTTP method for it as well. For example, C stands for create, and its respective HTTP method is post. Then we have R, which can be used as, which means read or retrieve, and it basically means to fetch data. And for this, the HTTP method is get. And U stands for update, and for update, the methods are put or post. Put is mostly used, but post can also be used. That's one important thing to note. And then for D, we have delete, and the method delete. Moving further, so it's important to understand like API hacking. So first, like why we need to know API hacking. So APIs carry like very important resources. And if we fail to secure APIs, we fail to secure the resources which APIs carry. So it's very important. And if I have to talk about what API hacking is, so API hacking basically emulates an external attacker targeting a custom set of API endpoints and attempting to exploit the security in order to impact the CIA, which is the confidentiality, integrity, and availability of an organization's resources. So if I have to talk about tools, like what do we have whenever we talk about API hacking tools? So you don't require many, because manual testing is what API hacking is all about. If it happens that you want to try, some automatic scanners, which web-based automatic scanners, what happens is that you will be left with a lot of false positives, and that's why it's not recommended very much. But it's not that there's none. We got few tools to help enumerate APIs. These tools are not exactly automatic scanners, which can, just fetch vulnerabilities and let you know what vulnerabilities exist in specific APIs. What happens is that they just reduce your attack surface, or they help you in, narrowing down your approach. So if I have to talk about the 2 most important tools, these would be Postman and Burp Suite. So what happens is that with these 2 tools, you can intercept requests, you can capture them, and you can review these requests. So these are very important because you can, send requests, send payloads to it, and then analyze the request and analyze the response for those respective requests. And you have other tools as well. For example, Kite Runner, Arjun, FFUF, and GoBuster. These are mostly used for enumerating, the endpoints or for content discovery. So you can use these tools as per your requirements. But for this session, we'll just assume that all you need is Burp Suite or Postman. So talking about OWASP. So OWASP stands for Open Web Application Security Project. So OWASP claims that APIs expose sensitive data and application logics. And therefore, based on that, OWASP came up with top 10 vulnerabilities, API vulnerabilities in 2019. So these are, number 1 is broken object level authorization. Then the second one is broken authentication. And the third one is excessive data exposure. So these 3 are the very commonly found ones, and these 3 are very important. We'll discuss these 3 in detail, but I'll just quickly walk you all through rest of the vulnerabilities. So the 4th one is lack of resources and rate limiting. So this vulnerability, basically what happens is that this vulnerability fails this API. So what happens exactly is that the API fails to impose proper restrictions on the amount of resources that are being requested, or the number of requests that will be that the user will be making. So this vulnerability usually is out of scope for bug bounties. But what happens is that if you're working as a security team, then it's very important to report it. So that's something important to note. And then the fifth one is broken function level authorization. So this happens, or this occurs usually in situations where, you know, different hierarchies or different privileges are involved. When someone, like, well, let's say a lower privilege user can access, you know, higher privilege users data, or, you know, perform actions which only higher privilege users can. One example would be, let's say there are regular users and then there are admin users. And if the regular user can somehow, you know, access sensitive data which only admin was supposed to, then it clearly becomes a case of broken function level authorization. And then we have mass assignment. So sixth one is mass assignment. So what happens is that, you know, a lot of additional parameters are sent with the API request, and these parameters are they actually work with the code. So what happens is that, let's say, for example, there's a parameter is admin, and that is admin parameter is set to true. What happens is that for, let's say, a regular user, if a regular user sends this parameter and the code somehow considers it to be legit, then the regular user will end up having, you know, sensitive data, access to sensitive data, or, you know, that regular user might happen to, you know, make changes or perform activities which only admin users can. So this becomes a problem for this becomes a huge problem, and that's why this vulnerability is called mass assignment. And on seventh, we have security misconfiguration. What happens is that this usually happens when, you know, default configurations are just full of security flaws, or you know, some error messages, or somehow some sensitive data is being revealed. By sensitive data, I mean like very specific, not user data, but system data or server data is being exposed. And then we have the injection. So this vulnerability is very common. This exists, I think, in almost all technologies, not just in APIs. So injections, these vulnerabilities are like the ones in which an attacker sends malicious payloads. And these payloads are, you know, they get executed as commands. And the user ends up, you know, the attacker ends up accessing a lot of data. And sometimes it might also happen that they can perform some damage to the application. For example, they could delete or modify or make changes to the sensitive data. So that is, again, a huge threat. And then we have improper assets management. So what happens is that, like, a lot of times, you know, patches are being made into the endpoints and a newer version is released. But if the older unpatched versions are released, if the older unpatched versions are, you know, exposed, or the attacker happens to find them, then it becomes a huge threat, because obviously they are unpatched, they have the vulnerabilities right in them. So it can reveal a lot of sensitive data. Again, it's a problem. And then lastly, we have insufficient logging and monitoring. This, I wouldn't say is a hacker's problem, or is something which the hacker should be concerned. But again, if you're working for like an organization as a security team, then you should report it. Then you should like talk to the concerned members who can, you know, the incident response team, you should talk to them and get this problem fixed. So as I said, we'll be talking about the top three. So first one is broken object level authorization. So in short, it is referred to as BOLA. And if you have like even a little bit of idea about web vulnerabilities, you must have heard of IDOR. And this is very much similar to that. So what can happen? So in broken object level authorization, what happens is that user A can access user B's data or even make changes on user B's behalf. So this again becomes a huge problem. And then the question is like, why this happens? So this happens because, you know, due to missing proper object level access controls. And I would say that one big reason for this is that usually developers ensure too much trust into the user, expecting that the user will only access their own data and not, you know, tamper the object IDs, or try to access someone else's data. And that's one of the big reasons why it happens. So moving further, what is an object ID? Applications often use an identifier for direct access to an internal implementation object. So identifiers are like a unique ID given to every user, and those that specific identifier is used to identify that user, to uniquely identify that user. But it's very important to understand that these object IDs do not provide any kind of access control measures. So like additional security measures need to be implemented. And if I have to talk about like what the value of object IDs can be, they can be anything. They could be numbers, names, or simply anything. And these are usually named as ID, PID, UID, or anything. They could be anything the developer pleases to name. So let's take one example. So let's imagine an e-commerce website. So the e-commerce website is www.sneakers.com. And let's say there's a user with the ID 1101. And this is the API. This is like the required API to access user details. So the user ID with 1101 tries to access their own details, and they are able to get their own details. So as long as this happens, it's absolutely fine. But what if the user tries to, manipulate the user ID, or tries to, access someone else's user ID? And let's say the user, looks at the ID, which is 1101, and tries to, change it and move it to 1102. And if that user tries to, access 1102 and is still prompted with someone else's data, then it becomes a clear case of broken object level authorization. Because in this case, user A, or let's say user with ID 1101, is able to access the data of user ID 1102. So this is like a huge issue. So one common way, or like one popular way to find these bugs, is that to create two accounts simultaneously and try to access the data of the second account through the first one. And if you're able to do it, it is definitely a BOLA vulnerability. So this is like very common, and that's why it's placed at number one. It's very prevalent and quite often found. So that's why it's number one. Moving further, we have broken authentication. So broken authentication again exists in like different technologies as well. So this is a very common kind of a vulnerability. But the term in itself, broken authentication, is a very common term for many vulnerabilities. So it's not just that it represents only one kind of vulnerability. It has like different kinds of broken authentication vulnerabilities. So I'll be talking about some of these. Again, this is not an exhaustive list. So the first one is missing authentication. So in situations, let's suppose that you're making an API call and you're fetching resources which reveal some sensitive data. There should definitely be an authentication process over there. But let's say the authentication is not there. So that's again broken authentication. And then the rest of them are like very common ones. So like weak usernames and passwords. Let's say weak usernames and passwords become very easy to guess or brute force. But again, like let's say the password policies have been like, you need to have an 8 character password. You need to have like uppercase, a combination of uppercase, lowercase numbers, and special characters. Yet let's say the user named Steve has a password Steve@1234. So this becomes like a very easy to guess password or easy to brute force password. But again, like in a lot of cases, the fault would be of the consumer or the user. So, but this again becomes a broken authentication vulnerability. Then we have like credentials stored in clear text, or credentials sent over unencrypted connections, or hard-coded credentials. So these again like reveal the password and the username. So this again like gives full access to the attacker. So these are like a very common kinds of vulnerabilities which are like very usually found. And then we have like hard-coded credentials. Then we have, sorry, the last two, which are exposed API keys or tokens. So what happens is that like API keys, these are like unique IDs which are, which a user is given at the time of user registration. And whenever a user makes a request and has added the API keys, it like identifies that user uniquely. So it's very important. So there are like tons of cases where the developers expose API keys or tokens, and they put it on, let's say, GitHub, and it becomes very easy for attackers to do a little bit of reconnaissance and just find these leaked API keys. So that's one of the vulnerabilities, very specific to APIs. And then we have improper API token generation. So in this, what happens is that, let's say, if the attacker somehow manages to know the pattern of API token generation, then the attacker can, guess the API tokens, or can, brute force them. So again, it becomes a huge broken authentication vulnerability. And so again, I would say this is not an exhaustive list. There are many more broken authentication vulnerabilities, but these are like the standard or the classic broken authentication vulnerabilities. So moving on to this one, this is the excessive data exposure. So again, if I have to talk about excessive data exposure, this is again a common kind of a bug for different technologies. A lot of data is being revealed, or sensitive data is being revealed. This exists even in web. So like, what exactly happens if we have to talk about excessive data exposure in APIs? API endpoint exposes more information than is needed to fulfill a request. And mostly it happens due to missing or improper restrictions. So let's say you ask for like your personal details or your user details. And if what happens, like, let's say you ask just for your order details. And apart from your order details, what if you get like someone else's details? That becomes a problem. So we'll see like quick examples. So what if like a consumer requests for their account info, but receives all users' data? Let's say the user with the ID 1101 tries to access their own data, but ends up receiving a lot of data, like, or let's say every user's data. That clearly becomes a issue of confidentiality, because it clearly reveals sensitive data. Here not just mobile number or username is being revealed here, the address and the email ID, all of these are being revealed of other users. So this is definitely not advisable, and this definitely becomes a case of excessive data exposure. And then we have, so let's say you try to access your card details or card info, and your user ID is 1101. But so if you, so this data absolutely belongs to you. So I don't think there's a problem in it. But as the name says, excessive data exposure, I think if you look very carefully, you will get to know that CVV is also being revealed. So what happens is that whenever, even if the backend sends all this data, the front end is supposed to, filter out the sensitive data. So CVV should not be exposed like this, because even if your card details are saved, you're supposed to enter your CVV every time you make a purchase. So this should not have been revealed. So this becomes like a situation where sensitive data is being revealed. So that's the end of this session. So I'll end it on like a important note. So let's say the world's most valuable resource is no longer oil, but data. And APIs are digital pipelines that allow this precious commodity to flow across the world in the blink of an eye. So this is a very important statement, or like say a quote from Hacking APIs book by Corey J. Ball. So I think we should keep this in mind and, try to learn more about API and how to secure them. So that's my time. Thank you, everyone.
Thank you, Alia. Thank you so much for the wonderful presentation. And I just open up if any one of you have any questions. And I will also quickly check the live chat box. Right, so we do not have any questions on the live chat, but I believe people who will be watching the session after this, or maybe in coming weeks, might have some questions or doubt, and I would request all of them to reach out to you and connect with you over LinkedIn and Twitter and get those answered.
Definitely, I'll be happy to respond to any questions.